Hello, chemistry students. Here's another section of Chapter 9, Section 2, focusing on mass calculations. So we're going to start by talking about mass calculations. Now, remember, it would be helpful if you have your chemistry toolkit out and in front of you. And remember the tools you have on your toolkit. You have those the 3 count tools that involve Avogadro's number. You have molar mass, that's grams and moles. You have molar volume, which is moles and liters. And then you have that new one that you just added, that mole ratio. And remember, our mole ratio is your only way to change from one substance to another. Okay? And as we do these stoichiometric calculations, remember the thing that we always need, whether we're given it or not, is a balanced chemical equation. So kind of continuing here, talking about mass calculations, what this means is that you're given a mass and asked to calculate a mass. And keep in mind that there is no mole balance, okay? What that means is I can't just take some substance and put it on a balance and it'll tell me how many moles it is, okay? So our only way for chemists typically is that we must measure the mass of a substance, typically in grams. Okay, so there is not some special magic instrument out there that I can put a substance on and it'll tell me how many moles it is. The only way I have to measure matter is to measure it either by volume, to measure it by mass or weight, or to measure it by counting, okay? There's not a mole way to measure it and directly. What that means for these calculations is that you're going to have to use more than one conversion factor. Okay, so we're still using all of our same tools, right? We have our count tools, which we probably won't use a lot in this chapter. Remember, our generic one is 6.022 times 10 to the 23rd representative particles over 1 mole of substance. Remember, we have our molar mass tool, right, which is some number of grams of substance over 1 mole of substance. We have our molar volume tool, okay, and to use that one we have to be at STP, right, and that's 22.4 liters of gas over 1 mole of gas, okay. And then we had that new one that we just talked about, our mole ratio, okay, and that was some number of moles of, we just kind of put an A to some number of moles of B. And again, these numbers here come from the coefficients of our balanced equation. Okay, so we're going to have to use several of these to solve these mass calculations. So the easiest way to kind of do this is to kind of look at an example. So our example is iron 3 oxide, also known as rust, is produced when iron reacts with oxygen. How many grams of rust are produced when 12.00 grams of iron rusts? Okay, now we're doing a stoichiometry problem. Remember, the first thing I need is a balanced chemical equation. So take a moment, pause the video, and go through your steps to write yourself a balanced chemical equation. If you need to do a word equation first, that's fine. From your word equation, you're going to do your skeleton equation. We're going to take everything and make it symbols. From your skeleton equation, you're going to add coefficients to make sure you follow the law of conservation of mass. Okay, so again, you should go ahead and do that. So part of this is iron 3 oxide is produced. So is iron 3 oxide a reactant or a product? It's a product, okay? So iron 3 oxide, that's an ionic compound, so my symbol for iron is Fe. It has a charge of +3. That's what the 3 is telling me. Oxide is O, -2. So I'm going to write iron 3 oxide or rust as Fe2O3. And it reacts from iron, which is Fe. Let's fix that a little bit. Fe reacts with oxygen. Now remember, for oxygen I need to write it O2 because it's part of Hofbrinkel, okay, it's that diatomic molecules. So that's my skeleton equation. Now I need to balance it. So I see my oxygens and I have a 3 and a 2, which means I'm going to have to make them 6. So I'm going to put a coefficient of 2 in front of rust, coefficient of 3 in front of oxygen, and a coefficient of 4 in front of iron to balance this. Now, this problem is asking how many grams of rust, okay, are produced when 12 grams of iron rusts. So again, I like to summarize what the problem is asking me to do underneath my balanced equation so I don't have to go back and keep rereading my problem. So notice, okay, this is a mass problem because I have grams and grams. And notice it's different substances. So what's my only way to change from one substance to another? I know I'm going to have to use a mole ratio. Remember, what are my only units on a mole ratio? Moles and moles. So that should kind of give you a clue. Somehow I'm going to have to change grams to moles, right? And my only tool that has that is molar mass. So I'm going to have to use a couple of these tools to solve this problem. Again, I still approach it the same way. I'm still going to start with my 12 grams of my given, which is iron. Now, where do grams of iron have to go? On the bottom. What can I convert grams of iron to? I use my chemistry toolkit, right? My only tool that has grams in it, the other unit is moles, so this has to be moles of iron. Remember, it's important now that I am writing the substances. Now, I like to go through and fill in all the units first and then come back and fill in the numbers. So I'm in moles of iron. I don't want moles of iron. I want grams of iron oxide. So that means moles of iron have to go in the denominator. And my only way to change from one substance to another is my mole ratio. So there's my mole ratio. And I'm going to go to moles of the rust because that's what I'm trying to convert to. Now I'm in moles of rust, but I don't want moles of rust. I want grams of rust. So moles of rust have to go on the bottom. Grams of rust have to go on the top. And that's going to leave me in the answer that are what I wanted, okay, in the units that I want. So notice here, in terms of my conversion factors, I've used molar mass. This one is also molar mass. And here I have my mole ratio. Okay, so let's talk about the numbers. Remember, easy number in molar mass is 1 because it's always 1. And again, I'm going to use just 4 significant figures here because I have 4 significant figures in my 12.00. So I look up iron on my periodic table. It's 55.845, so I'm going to use 55.85. Okay. Now I'm to my mole ratio. Remember, my mole ratio, my numbers come from my coefficients of my balanced equation. So in front of the rust, I have a 2, and in front of iron, I have a 4. So I'm going to put a 2 and a 4 in there. Now I'm back to another molar mass. Again, the easy number molar mass is 1 in front of moles. To get the molar mass for the iron 3 oxide, I'm going to add up 2 irons. So 2 times 55.845 plus 3 oxygens at 15.999. And again, I'm just going to use 4 significant figures. So my calculator gave me 159.687, so I'm going to call that 159.7. I want to make sure I'm using at least 4 significant figures because 12 here has 4 significant figures. Okay. So now I have all the numbers I need. I need to do my multiplication and division. Again, remember, I'm multiplying by my numbers that are in my numerator. And I'm going to divide by numbers that are in my denominator. Okay? The order that you do it doesn't matter because it's multiplication and division. Okay? And you should get, with 4 significant figures, I got 17.156. So this is going to be 17, oops, sorry about that. I'm going to get an answer of 17.16 grams of the rust. Okay, and again, if you need a moment to put that in your calculator and see that you're able to get it, go ahead and do so. Now, you'll notice on your outline that there's another problem. This problem asks, what volume of oxygen is needed to react with the 12 grams of iron at STP? So I'm going to go ahead and write my balanced equation again. So I have it to look at. Oops, nothing there. Plus, we had 3O2, gave us the 2 iron, 3 oxide. So this one is asking, what volume of oxygen, remember I'm going to measure volume in liters, is needed to react with the 12 grams of iron, and they do tell us it's at STP. Okay. So this last problem here, this was a mass problem because we went grams to grams. Technically, this problem isn't a mass one, right? This is a mass volume problem. Okay. But we still are going to do it the same way. We're going to have to use our tools. Notice again, we are changing from one substance to the other, so we know we're going to have to use a mole ratio. Okay. So we're going to start with our given, which is our 12.00 grams of iron. Again, I need to go from one substance to another. My only way to do that is a mole ratio. So if I look at my toolkit, my only tool that has grams in it is moles. Also has moles in it. Again, remember that tool has a name. Again, I don't want to stop at moles of iron. I want liters of oxygen. So moles of iron is going to go on the bottom. And I'm going to put moles of oxygen on the top this time because I'm trying to convert to oxygen. However, I don't want moles of oxygen. I want liters of oxygen. So moles of oxygen have to go on the bottom. Liters of oxygen goes on the top. Again, that's a tool that I have on my toolkit. Okay, and I'm going to have liters of oxygen. So again, the tools I've used this time, I used molar mass again. I used that mole ratio because, again, it's my only way to go from one substance to another. And this time I used my molar volume. So again, numbers for molar mass, easy number is 1 in front of moles, and we're going to use that same 55.85 as my mass from my periodic table. My mole ratio, I still get my numbers using my coefficients. My coefficient on oxygen is 3 and on iron it's 4. Molar volume, again, the easy number is moles, it's 1. And in front of liters, it's 22.4. So again, I have some numbers I need to multiply by. I have some numbers I have to divide by. Okay, remember I'm dividing by things that are in the denominator and I'm multiplying by numbers that are in the numerator. Okay, and again, I want to have 4 significant figures. So I got 3.6096. So I'm going to call that 3.610 liters of oxygen gas. Okay, so this would be a mass volume problem. Idea here is, again, using these tools, right? This is my chemistry toolkit that you hopefully have on an index card or a piece of paper. Using these chemistry tools, I can solve all of these stoichiometry problems. So your homework is on page 250, number 21. Have a good day. Talk to you tomorrow.